Hey guys, and welcome to the school station. Today's video is going to be about covalent bonding. This is from the AQA GCSE Chemistry 91 paper from the unit Atoms, Bonding and Moles. In today's video, I'm going to be talking about covalent bonding, what it is, and also about dot and cross diagrams. So let's just get right into the video. So first of all, we have to talk about covalent bonding and some information and facts that you have to know before starting this lesson. Covalent bonds are formed when atoms of nonmetals share electrons with each other. So what this means is that when there are atoms of nonmetals, they actually share electrons with each other. In the last video, I talked about ionic bonding, where we actually transfer electrons. We either lose electrons or gain electrons. However, this one, we can actually share electrons. Each shared pair of electrons is a covalent bond. So whenever atoms of nonmetals share electrons, you will know that a covalent bond has happened between them. Many substances containing covalent bonds consist of simple molecules, but some have giant covalent structures. You'll be seeing this throughout the examples that some covalent bonds are really simple to understand, whilst others can be really complicated and big. So now we're going to go on to some examples of dot and cross diagrams and looking at covalent bonding. This is an example that you actually may get in some of your worksheets or even in the exam. This question is to draw a dot and cross diagram of hydrogen chloride. So first of all, as we have watched in our ionic bonding video, you will know that we have to see in the periodic table what is the electronic configuration of each of the elements that we have been given. So hydrogen chloride is hydrogen and chlorine. So what we have to do is we have to find those in the periodic table, and we actually have to see what is the electronic configuration of each one of them. So hydrogen only has one electron, so the electronic configuration of hydrogen is just 1. Chlorine actually has 17 electrons, so therefore the electronic configuration for chlorine is 287. So now that we can actually look at these two electronic configurations, we can realize that hydrogen needs one more electron to become a full outer shell for it to become stable. And chlorine also needs one more electron for it to become stable. And when a reaction happens, the main aim is for both of the elements to actually get stable. So therefore, hydrogen and chlorine both need one more electron to become both of them stable. So what do? You have to share the electron. What you do is you actually give one of the chlorine's electrons to hydrogen and one of the hydrogen electrons to the chlorine. When you actually do this, you get HCl. And when you realize that you've actually done this, you'll realize that when we give this, we actually have 8 electrons for chlorine, and we also have 2 electrons for hydrogen, which is completely perfect. And that is the answer. This is how your dot and cross diagram should look like. If you haven't understood, do not worry, because now we're going to go on to the second example. This is a bit more of a bigger covalent structure, but do not worry, it is actually exactly the same method. The question is to draw a dot and cross diagram of methane. So you'll have to know what methane is. Methane is actually CH4, okay? So you actually should know that methane is CH4. It's definitely really important to memorize that methane is CH4, okay? So after that, what did I say before? We have to actually find the electronic configuration of chlorine and hydrogen. So, carbon and hydrogen this time. So carbon actually has 6 electrons. So carbon's electronic configuration is 2,4. The electronic configuration for hydrogen is 1. So now that we've known the electronic configuration, we have to now go on and actually realize the dot and cross diagram for it. So for chlorine, we only need still 4 more electrons for it to become a stable element, while for hydrogen we only need 1 more electron. So what we can do is we can actually again use a covalent structure to actually make sure that all the elements are stable. what we do is we actually give, so one hydrogen atom has one electron. So what we do is that we share it with the chlorine, the carbon. So the carbon also gives, the carbon already has 4 electrons in the outer shell. So it gives to each one of the hydrogens, okay? Because since it has 4 electrons, it can't just give 4 electrons to all of them to hydrogen. They have to share with 4 separate hydrogen atoms. So what they do is that carbon just gives 1 atom to each hydrogen atom, and hydrogen gives 1 of their atom to carbon. When you do this, you'll realize that you have done a covalent bond and all the atoms are actually stable, because then if you count it, you'll see that carbon actually has 1, 2, 3, 4, 5, 6, 7, 8, which is a full outer shell. Hydrogen in this hydrogen atom has 1, 2. It means it has 2 electrons, which makes it stable. Over here, this hydrogen also has 2 electrons. This hydrogen has 2 electrons and this hydrogen has 2 electrons. Therefore, all of these things are stable, and therefore CH4 methane becomes a full stable covalent structure. So I hope you guys have understood, because now I want you guys to try out a question. This question is to draw a dot and cross diagram of ammonia. So over here we've already been provided with what is ammonia. Ammonia is NH3. I want you guys to pause this video and have a go. Make sure to remember the facts we've learned today, and also go back and look at the examples if you're stuck. Alright guys, hope you guys have tried out the question, and here is the answer. So the answer over here is actually, so first of all, we know that nitrogen, we have to first look in the periodic table and see what is ammonia, NH3. So nitrogen actually has 7 electrons, and the electronic configuration is 2, 5, and hydrogen again has only 1 electron. So what do? We have to realize how many more electrons does nitrogen need for it to become stable. Nitrogen still needs 3 more electrons for it to become stable, while hydrogen only needs 1 more electron. So after that, what we can do is we can actually just share all the electrons that there is. So nitrogen already has 5 electrons. We can, since it already tells in the question that ammonia is H3, what we can do is we can actually share it to 3 separate hydrogen atoms. So what we do is we actually have, from the 5 electrons that nitrogen already has, it gives 3 of those electrons to 3 separate hydrogen atoms, and the 2 leftover electrons actually just gets left there. So this has nothing, it only is added to the nitrogen, but it doesn't make any effect to the hydrogen. But these 3 other electrons that nitrogen gave, it goes to 3 separate hydrogen atoms, and hydrogen also gives its 1 electron to nitrogen. Therefore, if we count it all together, we will realize that nitrogen has 1, 2, 3, 4, 5, 6, 7, 8, which is a stable element, and hydrogen also has 2 electrons. This hydrogen has 2 electrons and this hydrogen has 2 electrons, and therefore we know that all the elements are stable. I hope you guys have got the same answer as this, but if not, make sure to always practice and practice at home. Just as an overview of what we have learned today, we have learned what covalent bonding is. Obviously, covalent bonding is are formed when atoms of nonmetals share electrons with each other so that the elements become stable. We've also learned how to solve problems involving covalent bonding. As I said, make sure to practice some worksheets at home so that you're really confident with covalent bonding and dot and cross diagrams. Hope you guys enjoyed this video, and give this video a thumbs up and subscribe to the school station for more free science and maths lessons. Bye guys!